In this video, we're going to review exponent laws and give you some hints for being successful with simplifying exponent expressions. So let's start off by going over the exponent laws that we're going to see coming up in our problems. This first one is when we are multiplying two things together. Those two things have to have the same base. And in this case, what we're going to do is we're going to add the exponents together. So this would be a to the m plus n. I'll give an example here. If we add x squared times x to the fifth, that would be equal to the same base, x, and then add the exponents. 2 plus 5 is 7. Related to this is when we're dividing two things with the same base. So we've got the same base top and bottom. And in this case, we will be subtracting the exponents, minus n. So quick examples here. If we had x to the fifth over x to the first, we would subtract 5 minus 1, we would get x to the fourth. Let's give another example here as well. If we had x to the third over x to the 10th, we would subtract. 3 minus 10 gives us negative 7, which means we're going to have x to the 7th, but it'll be on the bottom. Nothing on the top, so we would have a 1 on the top. Now, most people, when they're actually dividing with exponents like this, rather than think of subtracting the exponents, what they're going to think of is the fact that you've got 5 x's being multiplied on the top and 1x being multiplied on the bottom. And they'll kind of envision what would happen if you were to cancel top and bottom one of those x's. You would have 4 left over on the top. Likewise, in this scenario, for this example, we would have 3 x's on the top and 10 on the bottom. We'd start canceling. All 3 of those x's on the top would get canceled. 7 would be left behind on the bottom, none left behind on the top, and so we'd have 1 over x to the 7th. Okay, moving on to our next rule. In this rule, this is called the power to a power rule. We've got a single base, and there can be, we can have more than one thing inside of parentheses, which we'll see in just a moment. But we've got a single base on the inside with an exponent on it, and then an additional exponent on the outside. And in this case, we will be multiplying the two exponents. This would be a to the m times n. An example of this would be x to the third on the inside raised to the 5th power. This is going to be x to the 15th. 3 times 5 is 15. All right, our next rule. People often call this distribution, and it's technically not, but it looks a lot like it. If we have more than one base going on the inside of a parenthesis and an exponent on the outside, then that exponent is going to be applied to everything on the inside. So this would be a to the n times b to the n. An example of this would be as follows. If I had 2x to the 4th being raised to the 3rd power, we would need to apply the exponent of 3 to both the 2 and to the x to the 4th. So this would be 2 to the 3rd times, now the x to the 4th to the 3rd, that's power to a power, so we need to multiply. This is going to be x to the 12th. And we'd probably want to simplify that one step further. 2 to the 3rd is 8. 2 times 2 times 2 would be 8. And then x to the 12th. All right, moving on just a few more here. This next rule is when you've got 1 as your base. And if 1 is your base, 1 to any power is just going to equal 1. Pretty simple rule, and there's another similar one. If you're taking any number to the 0th power, that's also going to equal 1. Now there is one exception to this. 0 to the 0th power is actually undefined. But any other number raised to the 0th power is going to equal 1. This next rule causes lots of headaches and a lot of problems for a lot of people. This is when you have a negative exponent. And technically, the way this works is if you have a to the negative n, that's equal to 1 over a to the nth power. I want to give a couple examples here. The negative exponent is going to cause that base to move to the other side of the fraction bar. and the exponent then becomes positive. So for example, if I had, let's say, 2a to the negative fifth over 3, we would take that a to the negative fifth, and it would move to the bottom of the fraction. Now the 2 and the 3 wouldn't go anywhere, but the a to the fifth would move to the bottom, and it is now a positive fraction. I'm going to give a couple more examples here as well. At least one more. Let's do one more. If I have a 1 over x to the negative third, the same idea happens if you get a negative exponent in the bottom of a fraction. This x to the third, since it's negative, exponent's going to move to the top. It's going to become x to the positive third. You wouldn't have anything left in the bottom. You could leave a 1 down there, or you could just leave it blank. Now, it is only the thing with the negative exponent that moves. That's why in this first example we looked at, the 2 did not move. Notice that the 2 actually has its own exponent on it. We never write it, but it's got an exponent of 1. Same thing with this 3 down there. It's got an exponent of 1 as well. And since it's got a positive exponent, it's going to stay put right where it is. Only the things with the exponents are going to move to the other side of the fraction. Okay, let's do our last rule here. A to the 1 over n is the same as the nth root of a. So, for example, if you had x to the 1/2 power, that would be the same as the square root of x. Y to the 1/5 power would be the same as the 5th root of y. Okay, so the big thing, you need to know all of these laws and be able to apply them correctly. People tend to mess up when they tend to multiply when they should be adding, and vice versa. Those are the biggest mistakes that I tend to see. I'm going to give you some hints that will help you through this. These are not hard and fast rules. The first two are very strongly recommended, though. Rule number 1, you should show your work with this. Okay, let's get over the idea that you can do work in your head, look at a problem, and write down the answer. Students who try to do that during this unit tend to do very, very poorly. You'll notice when I go through the example problems in the next video that I show multiple steps, even for relatively simple problems. And for more difficult problems, I might show 7 or 8 steps. I've been doing this a long time, and I'm not doing all those steps just to illustrate what's going on. I'm doing them because I need to, because otherwise there's so much going on that I'm going to make a mistake. Number 2, only apply one rule at a time. Try to stick with only one rule at a time and show each of those steps. This third one's pretty self-explanatory. You must pay attention to detail. Okay, this is going to be easier for you to do if you're only focusing on one step at a time, because one small mistake early on is going to get you the wrong answer in the end. And this unit is going to be assessed on accuracy. You cannot afford to make a small mistake. The other thing that I'll say, and this is definitely not a hard and fast rule, but I tend to take care of negative exponents and parentheses early on in the problem. Sometimes I do, sometimes I don't. There are lots of different ways you can work out these problems. Basically, as long as you're taking it one step at a time, going slowly and doing everything correctly, you're going to come up with the correct answer. You may do a problem completely different from me, but if we both do it correct, we should arrive at the same answer. All right, good luck with these. Remember to go slow and take your time and be accurate.